Good evening, this is Dr. Pradhan here. Welcome to NPTEL project on econometric modeling. So, today we will discuss the concept Trivariate Econometric modeling. So, in the last couple of lectures we have discussed the entire structure of econometric modeling, that to bivariate econometric modeling, the importance, the model fitness, the reliability, etc. we have discussed in details. So, here we will go little bit deep. Okay. So, the when we will talk about econometric modeling or regression modeling, because it is the counterpart of you can say it is same way we can represent in econometric modeling. So, the starting point is with respect to two variables, but the complexity will be very high, or you can say relatively very complicated. So, when we will move two variable to three variables, or you can say more number of variables. So, now we just like to know how this problem is more complex when we will add an extra variable in this particular system. So, what is the exact system? Then the starting procedure of means the starting of econometric modeling is with respect to two variables. So, with one variable you cannot do anything, or we cannot establish any relationship. So, the origin is with respect to two variables, but when we will add one after another variables, then the model beautiness will start increasing, and in the same times the complexity will start increasing, and you will find lots of interesting features, or interesting issues when we will integrate more number of variables in the systems, because in a particular setup, in a particular problem background. So, there are large number of variables which can influence each others. Okay. So, with the two variables we cannot get a best fitted models until unless, even if you check this, you can say reliability, etc. So, the model will be considered as a best fit, or can be used for forecasting or different use when the system is very consistent with the number of variables in the systems. Okay. So, that means multivariate model is more reliable more practically feasible than the bivariate model. So, bivariate model is just the beginning of this econometric modeling. So, there we start with various issues and challenges. So, now we will see how is this challenge and how complex this problem, how beauty is this problem when we will add one after another variable in the systems. Some of the problems we cannot detail explain when we are in the bivariate modeling, but when we will start with the trivariate modeling or multivariate modeling, that time that structure can be explained in a nice way, or you can say in a better way. So, we will see here including another variable in the systems. So, how is this entire structure or setup of a econometric modeling? But remember here trivariate means here. So, always independent variable is here only one, and more number of independent variables. So, means when we will start with the bivariate modeling. So, we have two variables, one is a dependent variable and another is independent variable. That means, your dependent classification and independent classification should be very essential, and it should be must. So, now for bivariate models, then obviously there are two variables only, one has to be dependent, then other side it is another one is independent one. So, the game is a simple one, but when the when we add another variable in the system, then in the typical situation or in this particular framework. So, we add more number of independent variables in the system, keeping y remain constant. So, that means whatever in the future couple of lectures. So, what we will see? So, we will discuss so many problems, so many issues, keeping one dependent variable with the net addition of independent variables. That means, one after another variables we will add to the system, and we will see how is the setup and how is the structure. This is one agenda or one structure of this econometric modeling, but there are certain problems where there are multiple number of dependent variables and multiple number of independent variables. Then we can also integrate each other to get a particular problem solutions. So, that setup is something different and is more complicated than the simple multivariate models, where only one dependent with the many independent variables, and that particular concept where the number of independent variables are many and number of independent variables are many. So, it is called as a structural equation modeling. So, we will touch that structural equation modeling in the later part of this means after so many lectures we will proceed to that particular, because that is more complicated than the present setup. So, we will discuss with the one dependent variable with several independent variables, what are the structures, what are the problems, what are the challenges, what are the shortcomings, etc. Then after discussing all these issues, then we have to introduce or we have to enter to this system where there are number of dependent variables and number of independent variables. So, now we will move to a process where there is always dependent variable, only one single dependent variables, and there are several independent variables. So, let us we will assume that the system is in such a way there is only one dependent variable here and there are two independent variables. So, that means this particular system is called as a Trivariate Econometric modeling. So, what is all about Trivariate Econometric modeling? Trivariate Econometric modeling means it is a econometric system where there are means there is one dependent variable and there are two independent variables. So, that means, so let us take a case here. So, once you will talk about dependent and independent. So, every time whatever concept we will discuss in econometric modeling. So, every time we will assume that the y setups, y series are dependent series and x setups, x series are independent variables. For instance, if it is y series here and x series here. So, within y series we have number of variables say y 1, y 2, y 3 like this. Then we have a number of variables say x 1, x 2, let us say x 3. Okay. So, within y 1 there is items like y 1 1, y 1 2 like this. Okay. So, similarly for y 2, y 2 1, y 2 2 like this, then y 3, y 3 1, y 3 2 like this. Similarly, for x 1 we must have like this x 1 1, x 1 2 continue, then x 2 1, x 2 2, then up to nth term, then similarly x 3 1, x 3 2 and so on. So, like this, that means what is my my point is here. So, we consider y setup is dependent classification, x setup is independent classification. So, we will see under y system how many variables are there and under x system how many variables are there. So, so in the y system if number of variables are there, we will recognize or categorize like y 1, y 2 up to y n. So, every items will be considered as a separate variables in the system. Similarly, in the case of x, so we will assume that and x number of variables are there and every number we will denote as a x 1, x 2, x 3. These are the variables in numbers. Okay. So, instead of putting y 1, y 2, y 3, we can simply write y I and simply we will write x I or x j, where I stands from 1 to n, then that means n number of variables. When y stands from I to k, then there are y dependent variables. So, now we will fix a setup here, so where there is only one dependent variable. So, if there is one dependent variable, then obviously there is no point to classify y 1, y 2, y 3. So, we will simply represent as a y. So, that means Trivariate Econometric modeling is a system where there is only one y. So, y there is no subscript. Okay. So, that means it is a simple y representation. So, that means it is one dependent variables at a time. Okay. So, this is one setup and y we have to integrate with several independent. This is dependent variable structure and this is independent variable structure. In this independent variable structures, since it is a trivariate, so we will take two independent variables x 1 and x 2, and corresponding to trivariate, when we are discussing bivariate econometric modeling. So, bivariate econometric modeling, we have dependent classification and we have also independent classification. In that case, dependent classification is y and independent classification is x. So, there is no x 1 or x 2 because, so there is only one dependent variable and there is another independent variable. So, that means in dependent classification only one variable and independent classification there is only one variable. So, there is no use of subscript or you can say any additional supporting component. So, that means for bivariate econometric modeling, the model will be simple to understand or simple to represent if we will just integrate y to x. That means, y is dependent, x is independent, but the system is more interesting or more complex in nature when we will introduce another variable. When we will enter another independent variable in the system, then obviously the x items will be start increasing. So, that means, since there are for trivariate econometric modeling, since there are two variables at a time. So, obviously, we will categorize or we will represent x 1 and x 2. So, that means, there is a need or it is essential to use the subscript to define, but we can represent like this. We will take y is one variable, x is another variable, z is another variable. So, we can integrate y with x z, where x and z are independent variable. But instead of putting like that way, so it is better we will put y with respect to x and use subscript. Then this representation is much easier and much simple. For instance, you see the how I can write all these issues here. So, what is the basic framework of modeling? So, we have to regress independent variable to dependent variable, just like in the case of bivariate econometric modeling, we are putting y equal to alpha plus beta x impulse. Then obviously, this is mathematical form of the model, and we are introducing error term, because some of the observation we cannot able to capture because of various reasons that we have explained lots of lectures back. So, here what is the point here? Similarly, we have to fit a models first mathematical form of the trivariate econometric modeling, then we like to introduce the error, because some of the variables again we cannot identify properly because of so much complexity or so much problem. So, obviously, there is the introduction of error terms. So, then like bivariate setup, we like to minimize this error component. We also do the same thing in the case of trivariate econometric modeling. In the case of trivariate econometric modeling, we will fix a mathematical form of the model, and we transfer this mathematical form of the model into statistical form of the model by introducing the error term, because in this particular system the starting point is we are assuming that x 1 and x 2 are influencing y, but that is not sure that only x 1 and x 2 will influence the y. There may be some other variables. There are some other variables which we cannot usually capture, can be considered as an influential factor for this dependent variable. For that reasons, it is bound to use the error term or introduce the error term. So, now by introducing error term, or you can say two independent variables in this particular system, then you see how is the setup. Okay. So, now let us assume that y consists of several items, say y 1, y 2 up to y n. Okay. So, this is how the y observations. Okay. So, we assume that y structure is like this, then x 1 is another variables which is structured as x 1 1, x 1 2 up to x 1 n. Okay. So, similarly, we will introduce another variable x 2 is a variables where a representation is x 2 1, x 2 2 up to x 2 n. Okay, x 2 n. So, the system is three variables, the integration of three variables, where y is considered as a dependent variable and x 1 is considered as a independent variable, x 2 is considered as independent variables. So, that means, it is the integration of two independent variables to dependent variables. So, as a result, the structure will be like this. This is y, and we have two independent variables. One is called as x 1 and another is called as x 2. So, what we like to do? We like to integrate x 1 with x 2. So, this process is like this. So, we start we like to know how much x 1 influence on y and how much x 2 influence on y. Okay. So, standard procedure as usual. So, we have to fit a regression model. So, by integrating x 1 and x 2 with y. So, that means, we like to know what is the influence of x 1 on y and what is the influence of x 2 on y and what is the overall fitness of the models, provided all these assumption or condition or constants should be in our hands. So, what is the actual process here? So, before going to actual process, so we assume that this is the y variables dependent classification, these are all independent classification. So, now the simple model of trivariate econometric modeling is like this. So, this is the initial setup. So, where there are only 3 variables altogether. So, y is the classification of dependent variable and x 1 and x 2 are the classification of independent variables. So, now if it is so, how will you proceed to feed the data and to get a best structure within the entire informations. Then as usual we will go for estimation process. Then again once we will get the estimated model, we have to go for the reliability of the models, like with respect to parameter significance level, and other side we have to go for the overall fitness of the model, that is R square and F, which we have just now discussed few hours back with respect to this bivariate setup. So, now what we will do here, so we will just follow the path of the bivariate econometric modeling, then we will little bit elaborate the concept, so that we can know how is the system or structure in the case of trivariate, where there is a 2 independent variable and 1 dependent variable. Let us see how is the entire setup. So, what we will do here? So, the system is a trivariate. So, y is the dependent variable and x 1 is the independent variable and x 2 is another independent variable. So, this so what we will do here? So, let us introduce the supporting terms called as a beta 1 here, and we will introduce the term beta 2 here. Okay. So, that means, in the case of bivariate econometric modeling, so we have y and we have x only. Okay. So, the integration is only 1. So, here we are using the term earlier called beta, because only 1. So, there is no concept of using subscript. So, here since we are using subscriptive to x variables. So, obviously, it is the supporting or parameters. So, we have to also use subscript. So, that the system will be very consistent, or you can say more feasible. So, as a result, how will we proceed with this particular structure? So, we will represent simple like this: y equal to we will call it beta 0 plus summation beta I x I equal to 1 to n. Let us say this is the usual format of the mathematical form of the model. So, this is the mathematical form of the model for multivariate analysis. Okay. But we are in the process to discuss the trivariate econometric modeling. So, when will we when we will talk about the trivariate econometric modeling, then we will just add one constant, then the model will automatically represent the trivariate issue. So, what is that constant? The constant is here, just you write y I equal to 1 and 2, that is all. Okay. So, 1 to 2, that means instead of 1 dash you put 1 to 2 only. So, then automatically this model will be limited to 2 variable setup. So, if I will put I equal to 1 to n, so then that means there are n independent variables which can influence the y. So, that particular setup is called as a multivariate econometric modeling. So, we will proceed with that multivariate modeling later stage, but in the meantime we will see how is the setup or structure and a feasibility of this trivariate system. So, that means with 2 independent variables and 1 dependent variable, how is the structure. So, now if we will put I equal to 2, then the model will be represented like this: y equal to beta 0 plus summation beta I x I. Instead of putting I equal to 1 to n, it is better to put I equal to 1 to 2 only. So, it will be automatically indicate that it is a trivariate econometric modeling. So, that means, this particular, if I will not write this ones, then it is indication that it is a multivariate econometric modeling. So, MEM. Okay. So, in this particular setup, if I will put like this, then it is called as a trivariate econometric modeling. Okay. This is called as a trivariate econometric modeling. So, now this is in fact in a implicit format, that means it is not clear cut how is it the exact setup. So, we will introduce in a explicit format, so that we can understand the system in a much easier way. So, what is the explicit format of this trivariate modeling? So, we will write like this: y equal to beta 0 plus beta 1 x 1 plus beta 2 x 2. Okay. So, this is more more simple than this one. So, this is little bit confusing in nature. So, when you are very smart enough, when you are a hardcore statistician or econometrician, that times this particular format has a such a beautiness, but in the beginning it should be very neat and clean, so that you can understand the particular system. So, now this is the complete structure of trivariate in fact, we cannot say that it is a econometric model now, because there is no error term. So, the moment you will introduce the error term, then it will be transferred to econometric modeling. So, what we can call it right now, y equal to beta 0 plus beta 1 x 1 plus beta 2 x 2 means it is a trivariate mathematical models. Okay. This is simply called as a trivariate mathematical models. Okay. So, in fact, this is also multivariate mathematical model, this is also trivariate mathematical model. So, now this trivariate mathematical model means, so we have y one part of the problem, so that is dependent, and another part of the problem we have two independent variables, that is x 1 and x 2. Okay. So, what we will do, we will transfer this mathematical trivariate mathematical form of the model to trivariate economic form of the model. So, what is how we will do that? So, what we will do, we will write y equal to beta 0 plus beta 1 x 1 plus beta 2 x 2 plus and error terms. Okay, plus and error terms. So, now the system will be represented as a trivariate econometric model, trivariate econometric modeling. So, this part is called as a explained part, and this is called as a unexplained part. Okay. This is called as a unexplained part, and this is total part. Okay. So, that means like bivariate structures, we like to know what is the influence, means x influence on y, and what is u influence on y. So, that means what is the explained percentage and what is the unexplained percentage. So, as usual, if the explained percentage is much higher than the unexplained portion, then obviously the model fitness or model reliability is very high, and it can be used for policy use or forecasting. But if otherwise other way around, for instance, if a unexplained item is substantially higher than the explained percentage, then in that case the accuracy of the model will be less. So, that is why you must be very careful the way you will design or the way you will fit, so that the explained percentage will be much higher than the unexplained percent. It is not simply much higher, it should be absolutely higher than that of unexplained percent. For instance, if I will make a division between explained and unexplained, for instance, if I will take a issue like 51 and 49, for instance, that means if the explained percentage is 51% and unexplained percentage is 49, just simple what we will call simple majority, then in that case the model accuracy may not be perfectly okay. So, the model accuracy will be perfectly okay if we will get explained percentage is just close to you can say 100, but it should not be 100. Even if it is 100, then there is lots of issues and complexity will start, means there are lots of questions coming into the mind, how it can be, means it is possible to get 100%, because most of the instance it is very exceptional case. So, the model accuracy, model reliability will be much higher if the explained percentage is substantially higher than the unexplained percent. So, if it is around close to ones, like around 90% 90% interval, then obviously the setup is more accurate and more systematic, or you can say more practical, more feasible. So, we have to see how it will be done. So, we first of all we like to know what is the econometric analysis behind this trivariate econometric modeling, and how will we get the estimated models. So, after getting the estimated models, so we will take examples, and we like to get the accurate estimated models, and then we will go for the reliability part of the model to test the significance of the beta parameters and the significance of the overall fitness of the model, that is coefficient of determination. But here there are certain interesting problems we will discuss in very nice way, that is adjusted R square, that is coefficient of determination, and the multi-coordinate issue, because coefficient of determination adjusted R square is more the means the feasibility, or you can say the beauty is more interesting when we will enter to the trivariate and multivariate systems. And in fact, multi-coordinate issue is the very typical issue, we will start here only, because in the case of bivariate there is no concept called multi-coordinate, because it is the it is the multicollinearity is the issue of independent independent variables relationships. Since in the bivariate setup there is only one independent variable, so the problem of multicollinearity and adjusted R square are, you can say, totally handicapped so far as the analysis is concerned. So, now the beautiness of these problems can be analyzed in an interesting way. So, when we will introduce another, or you can say third variables in the system, that too the starting point of trivariate econometric modeling. Let us we see how is this setup altogether. So, now in this particular system, so our setup is like this: y x 1, y x 1 and x 2. Okay. So, this is y, and obviously there is error terms. Okay, error terms. So, the integration will be like this. Okay. So, this is how the original setup here. So, now as usual, so here there is to analyze the complete problems. So, we have beta 0, we have beta 1 and we have beta 2. These are three supporting parameters through which we have to get the best fitted model. We will get the best fitted models, or we will get the first estimated model, then we will go for testing whether it is best fitted, or you can say best structural form. So, before that we have to fit the model in a proper format, so that we can get to know, or we can get to test the reliability part of the modeling. So, what we have to do here? So, the structure is altogether here to estimate beta 0, beta 1 and beta 2. You see, before you going to trace this or estimate this beta 0, beta 1 and beta 2, let me little bit highlight this trivariate econometric format. So, the we know we have discussed lots of assumption behind this bivariate setup. So, when you will fit a econometric models for the case of either for the case of bivariate or trivariate or multivariate, then the objective behind this particular modeling is to fit a estimated model, that to get the estimated parameters and the overall fitness of the models. So, that is how you need to have a substantial interesting problems and typical theory behind this particular problem, and the information through which the model can be used or test, or you can say check the validity. Okay. So, now the way we have discussed in the bivariate modeling earlier. So, we introduced the technique called as a OLS techniques. Okay. So, there are certain number of techniques available with you through which you can get the estimated models. So, like OLS stands for ordinary least square methods, then generalized least square methods, then weighted least square method, then maximum likelihood estimators method. So, like this so many methods are there. So, by using all these techniques, so you will get the estimated models. So, that means we like to know what is the estimated value of parameters with respect to beta 0, beta 1, beta 2. So, now we will start with also again here OLS technique, because the other techniques like GLS, WS and ML, this is more interesting when we will when we will face severe problem, then we will highlight all these issues in details, because at a time to, we cannot discuss each technique simultaneously. So, again we will start with the application of OLS technique, then you get the estimated model, then we will go for the reliability checking. But the thing is that you use any technique to get the estimated model. So, obviously, your objective must be to fit the model in such a way that that should be best ones. So, even if you apply OLS technique, WLS or GLS, still you have to go for reliability check. So, again we have to justify the best fitness of the models. So, in fact, WLS and GLS is more interesting, more advanced technique than OLS. Still we have to start with the first OLS techniques, then we will see how is the reliability structure and how it can be a substantially adjusted to get the accurate setup. Okay. So, this is how the accurate problem is all about. So, now in this trivariate econometric modeling setup, so what you have to do? So, we have to integrate x 1 x 2 u with y. So, now how we have to do? So, this is how we have to establish the structures, then we have to start the estimation process. So, now one of the interesting point is here that when we will apply OLS technique, there are standard assumptions we have discussed details in couple of lectures back. So, this one of the standard assumption is that First is error terms, error terms should be mean of error terms should be equal to 0. Okay, this is one of the standard assumption, and second assumption is that covariance of error terms ui upon uj should be equal to 0 again, should be equal to 0. Then third, covariance of ui and uj should be equal to units, that is sigma square u, provided I should equal to j, here provided I should not be equal to j. Okay. So, this is covariance of error terms. So, there are couple of error terms. The moment we will get error terms, then let us say we will again categorize various other variables, like once you have error terms we will call u ones, then we will create u 2, u 3, u 4 like this. So, the way we are creating x 1, x 2, x 3 like this. So, there are series of error terms again. So, the game boundary will be expanded accordingly. So, we will discuss that game boundary in different context on different situation when we will enter to the multivariate system, or you can say more advanced problems. But in the meantime, we will assume that there is a single error term, but for standard procedure of OLS technique, just we are highlighting this assumption in a brief. So, it will be again expanded properly, or you can say analyze in a structured way when we will go to the particular problems. Okay. So, this is first standard assumption is the mean of the error term should be exactly equal to 0, then covariance of error term should be again equal to 0. If not, then there is a problem called as a serial correlation or auto correlation. We will discuss in details in later part. And if the covariance of ui uj where I equal to j is not constant, that is error variance. So, then there is a serious problem. So, that is called as a heteroscedasticity problem. If it is so unit, then it is called as homoscedasticity. That means, homoscedasticity is the good fit for the econometric modeling, but heteroscedasticity means it is there is a huge problem for econometric modeling. So, in fact, we briefly highlighted little bit during the bivariate econometric modeling, but right now we will just again highlighting this issue, but the detailed discussion about these problems in the later stage. So, now this is sigma square u I of I not equal to I equal to j. Then another assumption we have put that covariance of u and x should be equal to 0. Okay. So, this is bivariate assumption. So, that means when there is a bivariate assumption, bivariate model. So, that time there is only one independent variable, that 2 x only. So, there is no way to represent x 1 and x 2. Okay. So, but here we are in the trivariate system, and that too we are two independent variables in the system. So, obviously, we will represent x 1 and x 2. That means, the standard assumption will be modified accordingly. So, what we will do that? So, that means, covariance of u upon instead of x we will put x 1. So, it will be equal to 0. Then another assumption we will add here. So, covariance of u upon x 2 again equal to 0. So, that means, there this particular setup and this particular setup should be equal to 0. This particular setup is called as a covariance of u upon x 1, and this particular setup called as a covariance of u upon x 2. Okay. This should be equal to 0 and this should be equal to 0. If that is so, then you know the use of OLS technique can be more practical or more feasible. So, otherwise the system will be inconsistent. Okay. We will discuss details when we will go to this particular setup. Okay. So, now what we will do, the standard problem we will discuss is here about this multicollinearity issue. That multicollinearity issue means the existence of linear relationship between or among various independent variables, but here there is no question of various, because there are only two independent variables. So, that means, just we like to integrate x 1 and x 2. So, this particular setup is called as a covariance of x 1 x 2 or correlation between x 1 and x 2. So, that means, covariance upon x 1 and x 2 should be equal to 0, should be equal to 0. So, that means, they should be completely independent. So, u and x 1 should be independent, u x 2 should be independent, then x 1 and x 2 independent. So, that means, whatever variables in the left side, whether it is with respect to independent variables or error terms, they should be completely independent. They should not have any relationship, or you can say covariance or correlations between them. So, means if there is a such relationship, then it will affect the model reliability, and I am very sure you will not receive any best fitted models, or you can say it will affect the reliability part of the models. So, that assumption or that condition should be tested and should be required for this model fitness. So, these are the standard tricks before we go for the estimation process. This is one of the serious problems we can at least detect at the trivariate system. So, it is usually not possible to discuss in the bivariate setup. So, now covariance of x upon x 2 should be equal to 0. Then as usual the standard other information must be there, like what we have discussed in the couple of lectures back in the beginning of the bivariate econometric modeling. That means, since there are 3 variables in this particular setup y, x 1, x 2. So, in all the cases the information should be consistent. So, that means, if it is y is consist of 10, then obviously x should be 10 and x 1 should be 10 and x 2 should be 10. If there is inconsistency between all these variables with respect to their sample size, then obviously we cannot go for estimation and you cannot go for getting the estimated model. So, this must be a very means urgent requirement for before going to estimate the model. So, this is most. Okay. So, first thing is your sample information must be very uniform with respect to each and every variables in the system. That means, there are 3 variables in the system. So, your sample size should be very consistent with respect to all these 3 variables. So, this is another assumption before going to apply the OLS or estimated models. Now, another thing is that, so here your sample observation should be consistently high. For instance, in the case of bivariate with little bit sample you can proceed, but here the sample size in fact it should be substantially high. For instance, since there are 3 variables in these systems. So, what we can represent in that particular system is called as or we denote as a items called as a k. K represents the number of variables in the system. So, number of parameters in the system. Since there are 3 variables in the system, so obviously there should be 3 parameters. By default it will be coming 3 parameters. So, now here k represents means k indicates 3. So, obviously k equal to 3, that means there are 3 variables in the system. So, obviously n should be substantially greater than to 3, but in the case of bivariate setups, so n should be greater than to 2, because there are 2 variables in the setup. So, now here there are 3 variables in the systems. So, if when n stands for sample size, then k stands for number of variables in the system, then the system will be more consistent or the model can be fitted. So, if n is substantially greater than to k. So, that means n should be greater than to k. So, n should be greater than to k. It should not be equal to k, even if it is equal, then there will be lots of problem. So, that is why I am not highlighting n greater than to k, n greater than equal to k. It is better to put n greater than k, that to high in numbers. So, there are actually the accuracy of sample size is very interesting issues. For instance, for simple problems, your sample size should not be less than to 30. If it is less than to 30, then model reliability is very in a other way around. So, it is very difficult to predict something else, even if you are getting the reliable model also or best fitted models. Still it cannot be used for forecasting, because your sample size is not substantially high. The sample size should be substantially high, that means n should be greater than to 30, provided means it should be in a bivariate structures, but in the trivariate structure it should be substantially again higher. That is the minimum requirement of the sample size before estimations. If that is not the case, then it is very difficult to use this model for forecasting, and obviously there will be serious problem on reliability testing. So, n should be substantially greater than to k. Okay. Then obviously the model will be correctly specified, because we are using here y equal to beta 0 plus beta 1 x 1 plus beta 2 x 2, but this particular format is in a linear setup. but there may be some nonlinear relationship or there is some different mathematical form of the models, because it may be in a nonlinear setups like logarithmic format or exponential format or any different shapes like quadratic or you can say cubic. Then in that particular structure the game plan will be altogether different, but in the meantime we are representing the simple structure, or we are assuming that they are linear in natures. Even if they are nonlinear in natures, we can transfer into linear format. That transformation rule we will discuss in details in the later part, not right now, but in the meantime we will assume that the association between these two variables with y should be linear in nature. So, that means it is linear in parameters. So, that means beta 0, beta 1, beta 2 should be linear in parameters. So, that is also one of the standard assumptions before you go for estimations. Okay. So, now with this basic background, so we have to set the, you can say we have to fit the trivariate econometric modeling. So, the trivariate modeling setup is y equal to beta 0 plus beta 1 x 1 plus beta 2 x 2 plus u. Okay. So, now you can also, what you can do, you can use also I here. I stands for or indicates the sample size structures. So, obviously x 2 I, so this is x 1 in fact, x 1 I, this is x 2 I. Okay. So, now as usual I have discussed a couple of lectures back that the particular model can be represented in three different formats, that is to cross sectional modeling and time series modeling and penal data modeling. So, this particular when we use the subscript I, then it becomes a cross sectional modeling. So, this particular structure or this particular identification is called as a cross sectional modeling, but when I transfer I to t, then it becomes the representation becomes, you can say, is a time series format, or you can say time series modeling. Then when we introduce both, you can say y I t together with respect to beta 1 x 1 I t like this. So, this is called as a cross sectional modeling. So, similarly, we will write y t equal to beta 0 plus beta 1 x 1 t, then beta 2 x 2 t, then u t, obviously there is u t. So, here there will be u I. So, this side is called as a time series modeling. So, similarly, if we integrate these two, then if we represent this situation, this is called as a penal data modeling. So, what we will do, this is p y I t equal to beta 0 plus beta 1 x 1 I t plus beta 2 x 2 I t plus u I t. Obviously, this when we will go for hardcore penal data modeling, then the intercept term also or can also vary with respect to sample setup and that too in cross sectional observation and time series observations. So, we will discuss in details when we will go for pure penal data modeling. So, in the meantime, there are three ways we will represent the trivariate structure, that to cross sectional observation, time series observation and penal data observation. So, now accordingly there are three different models which we have represented here in a nice way. Okay. So, now you see here. So, how do you go for this particular econometric setups? So, now y equal to beta 0 then plus beta 1 x 1 plus beta 2 x 2 plus u. Okay. Then as usual by bivariate objectives. So, we must have a very strong objective here. So, means similar kind of objective. So, your first objective is to get the estimated model. So, that means this is a econometric model, trivariate econometric model. So, now we will transfer this to a estimated models. Okay. We will transfer it to estimated model, call it y head. So, y head equal to beta 0 heads plus beta 1 heads plus beta 1 head x 1 plus beta 2 head x 2, but that is all. Okay. So, this is what the estimated trivariate econometric modeling. Okay. Estimated trivariate econometric modeling. So, we will call it equation number 1 and we will call it equation number 2. So, that means the objective of this particular process means we first process is we must have a trivariate mathematical form of the models and we like to test that particular model, then you transfer the trivariate mathematical model to statistical form of the model. So, that is what we will call it a trivariate econometric modeling. So, then once you have a trivariate econometric modeling setup, so our objective is to transport this particular setup into a particular estimated format. So, that is what we call it y head equal to beta 0 head plus beta 1 head x 1 and beta 2 head x 2. So, the way we will move equation number 1 and equation number 2. So, that is very, you can say, interesting. So, what is your agenda here? So, we like to know what should be our objective. We like to know what is beta 0 head, what is beta 1 head and what is beta 2 heads. Okay. So, we like to know. So, you like means we like to, our objective should our objective must be to get y head. So, y head equal to beta 0 head plus beta 1 head x 1 plus beta 2 head x 2. So, that means the way we will move transformation from equation 1 to equation 2. So, it will be by default or assumption that we are minimizing the error term. So, that means the way we will minimize the error term. So, the equation 1 will turn into equation number 2, that is how we have to apply this OLS technique. So, now the standard idea is it to apply OLS technique. First you know you get the error terms. Okay, what is exactly error term? So, now as usual so, y can be represented as a y head plus e, okay, y head plus e. So, that means this is y head exactly it every times whether it is a bivariate format or trivariate format or multivariate format. So, y head is the summation of or influence of all independent variables together. Okay. So, this is the this is otherwise called as a the explained percentage. Okay. And whatever not explained, that is represented in the error terms. Okay. So, that means the total y is typically influenced by the explained item which is represented in y head and another is represented in e format, okay, that is error format. So, now you know when we will go for reliability, it is also again the same structures, total sum square equal to explained sum square and residual sum square. So, by the way you will get again y head square y summation y square equal to summation y head square and summation e square. In fact, the you know formula and the derivation is a little bit complex and something different than the bivariate setup, but the structure or you can say steps are more or less same. So, now what you have to do? So, the y the total percentage or total variation y is influenced by the explained variance, explained percentage and unexplained percentage. So, now so we get to know what is E. So, E is the difference between y minus y head, E is the difference between y minus y head. So, that means what is y head here? So, y head is here represented beta 0 head plus beta 1 head x 1 plus beta 2 head x 2. So, what we have to do? We will just represent here. So, y minus, instead of writing y minus y head, we can write y minus beta 0 heads plus beta 1 head x 1 plus beta 2 heads x 2, okay, beta 2 head x 2, okay, put it here bracket. Okay. So, this is what we call it E. So, E is defined as the difference between y minus the sum total of beta 0 head plus beta 1 head x 1 plus beta 2 head x 2. Okay. In fact, when in the case of bivariate setup, we use the parameters called alpha and beta. Okay. Since there is only one x, we are using beta intercept, but you can start with like you know beta 0 and beta 1 x 1. So, it can be possible, but you know since there is only one variables in that particular setup. So, we are not introducing extra intercept term. So, that is why we are representing simple x. So, since we are using simple x, so that is why we are introducing the beta concept only. And in on the contrary, for intercept we are using another constant called as a alpha heads, but the game is a very interesting, more you know eye catching when we will go for trivariate modeling. So, in the case of trivariate modeling, we are not using any separate we are not using different parameters altogether, because the moment we will use different parameters altogether, there may be some understanding problems for beginners, and in the same times and there may be lots of confusions, and you know the model beautiness will also get affected here. here the model beautiness will be interesting, and once you will set the system with respect to only beta. So, since we have two variables x 1 and x 2, so we are introducing beta 1 there, and for x 2 we are introducing beta 2. So, obviously, we can start with the concept called as a beta 0, that is the supporting component. So, beta 0 is the supporting, that is interceptor, and the beta 1 is the supporting component of x 1 and beta 2 is the supporting component of x 2, right. So, now the process of integration. So, we will get the error term, which is the difference between the true value y minus the estimated value y hat. So, by default the error term is nothing but y minus, if I will simplify further, then E equal to y minus beta 0 heads minus beta 1 head x 1 minus beta 2 head x 2. Okay. So, this is how the entire system altogether. Okay, altogether. So, what is our objective here? What is our objective? As usual in the bivariate structure, we have two strong objectives. Okay. What is these two strong objectives? Let me highlight here once again. So, E equal to here y minus beta 0 heads minus beta 1 head x 1 minus beta 2 head x 2. Okay. So, now our objective is to get the beta 0 head, beta 1 head and beta 2 heads. So, how do we go for that? So, now since our objective is to get the all the parameters, that is with respect to beta 0 head, beta 1 head and beta 2 head. So, we like to minimize the error sum square. So, as usual the bivariate setups. So, what we will do? So, we like to know what is the error sum squares, then we have to apply the OLS techniques to minimize that error sum squares. Okay. So, what is the error sum squares? The error sum square will be represented as a summation E squares, obviously I is there. So, I equal to 1 to n and is equal to summation y minus beta 0 head minus beta 1 head x 1 minus beta 2 head x 2. So, obviously, it will be squares. So, I equal to 1 to n here, and obviously, this is x 1 I, this is x 2 I and this is y I. This is the starting procedure of estimation. So, that means, we have to apply here OLS techniques, that is ordinary least square methods, ordinary least square methods, standard ordinary least square methods to minimize this error sum. So, again we have to go for optimization technique, technique, because here since we like to minimize the error sum, then obviously, we have to go for minimization principle. By standard format, again we have to follow the necessary condition and sufficient condition, but we have to see how we have to minimize the system. So, that means, here the minimization system is with respect to beta 0 head, beta 1 head, beta 2 heads. So, the way you will minimize. So, we have to differentiate with respect to summation E square with respect to beta 0 head, summation E square with beta 2 beta 1 head and summation E square with beta 2 heads. Then altogether we will simplify, then we will altogether get a system, simultaneous equation systems, where there are 3 equations with respect to 3 variables. So, that means, if we will solve this particular 3 equation, which is derived from this OLS technique, from this standard error sum squares. So, we will get the estimated value of beta 0 head, estimated value of beta 1 head and estimated value of beta 2 heads. So, now all these details we will discuss in details, that is in the next class. In the timing, it is not possible to discuss, we will start and within 1 minute we cannot finish this job. So, we will conclude this session today here. So, we will discuss detail this session in the next class. Thank you very much. Have a nice day.